Hello everyone, welcome to Reactify Labs. Today we will do the Leetcode problem, insert greatest common divisors in linked list. Okay, so it's problem number 2807 and it's a medium problem. Okay, cool. So I'm pretty sure this is not something like which needs a lot of explanation, because it's kind of like the problem which needs writing code. Okay, because the logic is really simple and all you need to spend your time on is writing the code, focusing on your syntax and all. Okay, so let's see. As the problem statement says, I'm pretty sure you would have known what this is expecting. So there will be nodes of the linked list and you have to insert greatest common divisor. Okay, let's read the problem statement. Given the head of a linked list in which each node contains an integer value, between every pair of adjacent nodes, insert a new node with a value equal to the greatest common divisor of them. Okay, and you have to return the linked list after insertion. Okay, so if you see, the problem statement says that node contains integer value, like each node of the linked list contains integer value, and it does not specify whether positive or negative, so we can assume that it can be positive or negative. Okay, but when you go to the constraints, you will realize that the node value, the constraint says that the node value can be 1 to 1000 only. So it means it will always be positive integer, not a negative integer. Okay, so that's why constraints are important. Okay, and total number of nodes in the linked list, it can be maximum 5000. Okay, this is also mentioned in the constraints. Okay, now as it says, between every pair of adjacent nodes, insert a new node. Okay, so let's say you have two nodes 10 and 20. This is your linked list. Okay, so between them you have to insert what? Their GCD. Okay, what is GCD? GCD is greatest common divisor. When we were kids in mathematics, we used to call them HCF, highest common factor. Okay, so GCD, if you don't know, is what is the largest number which can divide these two. So if you see in this case, the largest number which can divide both is 10, right? If let's say you take a number more than 10, for example 20, yes, 20 can divide 20, but 20 cannot divide 10, right? You can take a number like let's say 2. Yes, 2 can also divide 10, but 2 can also divide 20. 2 can divide 10 and 2 can also divide 20, but 2 is not the greatest, because there is another number which is greater than 2, right? 5 is greater than 2, which can also divide both. 10 is greater than 5, which can divide 2, which can divide both, but there is no number which is greater than 10. Okay, so that's why GCD is 10. So in this case, what we need to do is we have to modify this linked list, okay, and insert their GCD in between. Okay, so that's what we need to do. Okay, let's understand it with another example that's given here. So there is an example which says 7. There is a linked list which has only one node, it is 7. So for this, the answer is also 7, because you have to insert a node between two nodes. Okay, and GCD is also calculated for two nodes. You need at least two nodes for it. If it's not, so your base case, you can say that, okay, if there is only one node, then you will have to do nothing, just return the head. Okay, other case is, let's say other example, let's see 18, or you can say case, yes, which means more than one node in the linked list. Okay, 18, 6, 10 and 3. So if you see, this is a linked list. Now what is the GCD of 18 and 6? The GCD of 18 and 6 is 6, because there is no other number which is greater than 6 which can divide both. Okay, so we break this list here. Okay, and we make another node and make that node point to the 6. Then another GCD of 6 and 10 is 2, because there is no number which is greater than 2 which can divide both. Okay, so it will be 2. Okay, next is the GCD of 10 and 3. What is the greatest number which can divide both 10 and 3? So that is 1. Okay, so you have to return this, and your final answer would be 18, 6, 6, 2, 10, 1, 3, and you return the head of this. Okay, you return this, and that's it. That will be your answer. Okay, so that's what you need to do. How would you do it? Let's see how would you do it. So you are given a head, right? You are given a head. So you have a head. Let's say you take 2 pointers. One is first will initially point to head. You leave head as it is. You don't move head. Okay, so that's why you move other pointers, so that you can in the end just return head after doing all the modifications. Okay, first is head, and let's say second is what? Head next. So your base case can be if second, or you can write it before this also, like if head next, if this is null, then just return head, right? You can do that. Okay, what else? Other thing would be you make a GCD function. Okay, generally GCD functions come as a library function. Okay, so in C++, if I'm not wrong, it is underscore GCD, and it expects 2 numbers A and B. Okay, I don't know what the function is called in your language. Whatever it is, just you can use that, or it's not very tough. You can just write basic code for calculating the GCD. That will also be helpful. Okay, I'm not going to go into the depths of how GCD is calculated. You will find that anywhere. So let's say we call the function GCD A and B. Okay, so what you can do is else condition. It means you have returned. It means whatever we write before after this will be else. Okay, it means we did not return here. So now what we can do is we will calculate the GCD of this. So let's say int GCD, let's say underscore GCD is GCD. We call the GCD method which we have defined earlier, or you can use the library. GCD of what? First data and second data, because it's a pointer, right? It has 2 things, data and next. Okay, so it's a node has 2 things. The definition of linked list node has not data, actually Leetcode calls it val. Okay, so val and next pointer. Okay, so we use val, and this will give us the GCD. So what we can do is we can use this GCD value to create a new node. Okay, so it is called list node star, let's say temp. Temp is what? Temp is if you say it is the new node, new list node of what, which we made from GCD. Okay, don't worry about syntax too much here. I'll give my code in the description. So I'm just kind of like treat it like a pseudocode. Okay, so what we can do is we will just write a while loop, like while first is not null. Okay, while first is not null, we just do this. Okay, then what we do is first, actually while not only first, it is second also. So while first or second, or while first and second, so both should be there, right? For example, this if this is like this, so your first is here, your second is here, right? Now next your first will come here, your second will come here. In the third time your first will come here, your second will come here. So it's like while second actually. So we can just write while second. You don't need to worry about first. Okay, so while second exists, we will calculate. If second does not exist, for example, we know second does not exist, it means there will be no node which will be added here. Okay, so that's it. So while second exists, so what we will do is we will do it like this. The next of first will point to temp. Okay, temp will point to second. Okay, so what we did, we had this node initially, right? We have it these like this. So this was first, this was second. Now after the modification, what we did, we added a new node here which is next. Okay, first is now pointing to next, sorry, not next, temp. First is now pointing to temp, temp is now pointing to S. But what else? So we move first. So now this will become first and this will become second, right? So first will become second, will become first, and second will be second next, second next. So the next of second will be here. So now first second comes here. Again this while loop will be repeated. Now again it will say that okay, this second is not null. So again GCD will be calculated and again new node will be inserted here. And next time when the first and second moves, first will come here, second will come here, and you will see second is null now. When second is null, the while loop stops and we will have our answer. Okay. So this is not a very difficult problem. Actually it is tagged as medium, but yeah, since it's tagged as medium, we know it's not difficult. And also it is quite not something which would require you to think a lot. It's just when somebody asks you this question, it means that they want to test your code writing knowledge. Okay, how fluently you can write good code. Okay, so these are the kinds of questions which can be asked in the interview. Because see, there are two kinds of questions. One which tests how you write code, one which tests how you solve problems. Okay, depends on the interviewer. If interviewer wants you to test on how you solve the problem, he will not expect you to write the code properly. But if the interviewer wants to test you on code writing, he will give you some simple questions like this, and he will expect you to write a working code so that he can run it on the available test cases, and he will also expect that those test cases run properly and you should pass all the test cases. So when the questions are easy, kind of think of like it's a good news for you, because you don't have to spend your time on thinking and worrying on whether you will be able to solve the question or not, because that's actually something very concerning. You get you get panicked in the interview and you are not able to solve the question. And sometimes what happens is after you get out of the interview, the solution clicks, right? So you don't need to worry about these things in these kinds of questions. All you need to do is focus all your energy in writing the code. Okay, so that's it. It was a really short video, and thank you for watching. I hope it helps. Please remember to like, share and subscribe. I will see you in the next one.